Hello class, and thank you for watching this video on the review for test number one. The 20 questions I'm going to go over in this video are the exact same 20 questions you can expect to see on the test. The only difference is that the order is going to be different and the answers will also be changed as well. Now, whatever grade, I do have a this review again available for you to practice on our Canvas. And whatever grade you earn on this review, 10% will be added to the test one as an incentive for completing it. Now, the question number one. So let's begin. So question number one, we have the function f and g, as you can read it, and we have to indicate, we're going to perform the indicated composition. So we want to do the composition of fog first, and then golf on the second one. So for the first one, to do this composition, since we want to get fog, this means that the function g needs to be plugged into the x of function f. So for part A, we're going to replace the x with negative 6x squared plus 8, and then minus 5. So as you see right here, this is the x minus 5 that you see right there, and all I'm doing, like I mentioned, is replacing that x with that value. Now, this can be, again, your answer, so you can simply write that. In this situation, with or without the parentheses, doesn't really matter, but your answer will be acceptable as this. Now, if you want to simplify it, you can. So dropping the parentheses and combining the like terms, this is also an acceptable answer here. So whether you just do this or simplify it, you'll get, again, credit. The idea is that you know, again, what direction you're plugging it in. So that's why you have this second piece right there. And let's now look at golf. So to do this composition, we want to perform the composition in opposite order. So that means that now this is going to go into the x of g. So that would be negative 6 x minus 5 to the second power plus 8. So if you do at least this correctly, that is acceptable for the correct answer. And you don't have to simplify it. Even though it says simplify your expression, you really don't have to. This, again, will be marked correct. Now, if you do plan to simplify it, the proper way to simplify it is to write the x minus 5 a total of 2 times, since it's raised to the second power, bring down the 8, and multiply these three things together before you can add 8 to it. So let's do exactly that. I recommend that we multiply first these two binomials, so we could end up with x squared minus 5x minus 5x. Okay, so first outer, inner, and then last. And then we can bring down the 8. Let me zoom in right here. Now, since this is now, what we could do now is distribute. I was going to hit myself. We could now distribute and multiply all of these values by 6. And as you can clearly see, again, we have a set of like terms. So this is technically a negative 10. So let me write that over in this color in gray. So this is technically negative 10x. So distributing the 6 inside there, we'll end up with negative 6x squared, negative 60x, and negative, what's this, 150? Yeah, negative 150. And we're going to bring down the 8. So now negative 6x squared minus 60x and negative 150 plus 8, that equals to a total of negative 142. Excuse me. So this would be the simplified form and also an acceptable answer for the golf of x. But as long as you understand that what this notation means, again, how this composition order and the difference between those two compositions, then you don't have to necessarily simplify, only if you wish to. For example number 2, we have two functions, again, f and g, but this time we want to perform this operation, which this operation is multiplication. So we want to get the function 4, in parentheses, negative 4x squared minus 2, and multiply that with 8x plus 6. So to do this multiplication is just FOIL. So first, multiply each first in binomials, which is negative 32x squared. I don't know why I have an extra square there. That should not be an x squared. That should just be x. And now we're going to multiply these two, which is negative 24x, the inner, and finally the outer values. Now, you do have to simplify this expression. You cannot leave it like this because you do have a set of like terms. This will be marked incorrect. So you, unfortunately, unlike number one, you do actually have to simplify. So the simplified form, when you combine those two terms, well, since it's both negative, negative 24 minus 16 is a total of negative 40. And don't forget the x, minus 12. So there is your solution. Moving on to question number 3. Here we want to find the inverse of the function as long as x is greater than or equal to negative 9, which again really doesn't mean anything. So this part right here is just a condition to define that the inverse is going to exist for this thing. So we have to start by first, well, flipping our input and output values, flipping our x and y. So instead of y equaling to this, we're going to write 7, and we can ignore this. And we're going to write 7 square root of y plus 9 plus 4. And we're going to set that equal to x. And our objective here is to solve this equation for y. In other words, isolate the variable y. So we want to do the opposite of PEMDAS, undo PEMDAS, in order for the y to be by itself. So starting from the bottom, we're going to look for any addition or subtraction that we have on the outside. Because this right here, even though we have a plus 9 right there, that's being grouped inside these invisible parentheses, the square roots. So we have to worry about that until the very end. So we're going to start looking for first any addition or subtraction outside the parentheses, which you see we do. We have this value there. And because we're adding 4, the inverse operation of adding 4 is to subtract. So we're going to subtract 4 from both sides. So minus 4, and 7 square root of y plus 9 equals to x minus 4. We won't combine these two because we're solving an equation. We don't know what the value is. So x minus 4 is just going to be written as x minus 4. We are now going to now divide both sides by 7. Since we already did this, we can now move to multiplication or division. And we do have a multiplication on the outside. We're multiplying again by a 7. So the inverse of multiplying by 7 is dividing. So we're going to divide by 7. And we end up with y plus 9 equals to x minus 4 divided by 7. So we're done with that. We're now going to worry about exponents. Well, this is technically an exponent. Taking the square root of something is technically the raise something to the 1/2 power. So we are going to get rid of that exponent by raising it to the second power. So this and this cancels out, and we end up with y plus 9 equals x minus 4 divided by 7 to the second power. And now, having done all of this, then we can worry about what's in the parentheses by, again, inverse operation, and looking for, again, for any addition or subtraction. And then if there's multiplication, division, and if there's an exponents, we continue with that. But here, there's only addition and subtraction. So there's an addition problem there. So we're going to subtract this value to both sides. So we end up with y equals x minus 4 divided by 7 to the second power minus 9 since I'm moving out here. And because our parentheses again is grouping all of this together, I can't put that 9 inside here because this is again enclosed because of the square. So we can't do anything else after inside with that. We couldn't do anything else inside there because of that square from this step right there. So this right here is going to be our, let me box it in. This right here is going to be our answer. And you only have to write again this part that I've highlighted in blue because the notation of y is this notation right here. So this is that. So we don't have to write that in yellow. Only what I've highlighted in, or boxed in blue. This one right here is question number 4. They got cut off from the previous page, and you'll find it in the back page. So the function f is represented by the table shown below at selected values of x. And what we want to do is use this table here in order to figure out the input and output values for g, which is a transformation of these numbers there. Now, recall that since the x values are your input values are going to be changed by what's inside the parentheses. So these numbers that I'm going to highlight in green are going to be affected by these operations here. Now, like I mentioned again in our notes for this section, our input values are affected again in the inverse operation of our notation. So here, we're not going to multiply by 1 over 4. We're going to do the opposite operation, and these input values are going to be divided. So I'm going to write x, and they're going to be divided by 1 over 4. And instead of subtracting the number 2 to the x's, we're going to do the opposite operation and add the number 2 to those x's. And the reason we're doing this first, because again, in PEMDAS, multiplication again takes priority over addition. So here, in the terms of the transformation, again, the dilation takes priority over translation, over sliding. So let's do those operations again to these 5 numbers. So starting with -9 divided by 4, that's going to give us a 36, and 36 plus 2 is a total of 38. And now the next number, oh, I'm sorry, not 38, because this was a -9. So let me try that again. It's a -9 divided by 1 over 4. That's -36, and -36 plus 2 is -34. My error. Now, the same thing with -7. -7 divided by 1 over 4, that's -28. Plus 2, that's -26. Now, -5 divided by 1 over 4, that's -20. Plus 2 more is -18. -4 divided by 1 over 4 is -16. Plus 2 more is -14. And then finally 6. 6 divided by by 1 over 4 is 24, plus 2 more is 26. Now, since the f of x values, which again is another fancy way for y, since the y values are your output values, those numbers that are, let me highlight in purple, those numbers are affected by the outside operations. So if I ignore this, and I think about this notation as 3 times f of x, ignore what's inside there and just assume that's only x, plus 5, our output values are going to be affected by these two output operations, by these outside operations. And as you see the notation, we're going to do exactly again that to the f of x value. So right here, we don't change the operations, and these f of x values, these right here, will be multiplied by 3 and increased by 5. So no inverse values there. We just do exactly what it says to the f of x values. So our y values will be multiplied with 3, and we're going to increase 5. So again, from left to right, starting off with 9. 9 times 3 plus 5, that's a total of 32. 6 times 3 plus 5 is 23. Negative 4 times 3 plus 5 is negative 7. 2 times 3 is 6 plus 5, that's 11. And negative 1 times 3 plus 5 is 2. So there is your table for G. Now in example 5, we have two more functions, and we want to evaluate again the following composition. So we're not going to plug one into the other. We want to plug in again and get an actual numerical value for this. So what this requires us to do is to evaluate f of g specifically at the number 38. So our first thing to do, let me move this over here to the side. Since question number 6 was cut off, let me use the bottom part of the page. So right here, okay? So what we need to do first is figure out what the value of the inside is. So we need to figure out what this side equals. So what does g of 38 equal? Well, since g of x is simply x minus 7, g of 38 would be 38 minus 7, which is a total of 31. So what are we going to do with that 31? Well, since we know that this equals to 31, since we know now that this equals to 31, I can replace that with 31, and we're going to now figure out, so that's step 1. Step 2 is now to figure out what does f of 31 equal. All I've done again is replace that yellow with that value of 31. So I'm going to plug in the 31 into f. And since f of x is the square root of x plus 5, f of 31 would be the square root of 31 plus 5, which is the square root of 36, which is the value of 6. So our answer to this example is 6. Now question 6 was cut off from the previous page, so this is question number 6. And for this question, we want to draw the graph of g, where g is defined as f of x minus 1. So we're just simply translating this. So the minus 1, there because it's on the inside, is affecting again the input values, our x values, is going to have the opposite effect. So we're not going to move to the left one, we're moving to the right one. And since the minus 2 is on the outside, that's going to affect the output values, the y values, in the direction that we see here. No inverse, no different operation. So minus 2 means down 2. Now to do this again on the software, remember like I mentioned, you have to use this point first, because on the little icon that you see down here, you have again a marker indicated there, another marker there. So you have to start again at that indicated marker there. So we're going to move that point first. So 1 unit to the right, 2 units down, we'll move it to that location at 2, 0. And then using any other pretty point, for example, let me find this one over here on the right, on the left, I'm sorry, that one right there. 1 unit to the right and 2 units down, we'll move it there. I probably should have done it in a different color. Let me do it in blue instead. And the graph will automatically again connect itself. So this again, graph will go like that. It'll do this, and then again go through the appropriate places right there. So you just need to find again, use this point for sure, and then any other point to plot it. And you're going to simply again understand that this needs to move to the right and down, and the graph will draw the rest of itself. Draw itself afterwards. Now for question number 7, we have that f of x is defined by this quadratic, and we want to figure out the value of f of 5. And also figure out the values of x in which f of x equals to the number 28. So to do this part, f of 5 means that we're going to replace the x values with 5. If you use decimals, again, that's just simply using again to substituting the values in, which is the equivalency of doing this. So we want 5 to the second power minus 11 times 5 plus 28. You end up with 25 minus 55 plus 28. And then adding these numbers from left to right, this is going to end up equaling to a total difference of -2. You end up with -30 plus 2, which is -2. So that would be the answer of that. I think in the video that I have attached to this question, I use Desmos and I show you exactly how to use Desmos. But if not, you can just simply use Desmos. Type in exactly this on line 1 on Desmos, and then on the second line, type in f of 5, and you're going to get, again, the solution of that. I think that you could even do this, type in f of a 28, and it also does solve the equation for you. So you know what, let's just do that on this video, just in case I didn't do it on the video that I have attached there. So we're going to write f of x equals x squared minus 11x plus 28, and f of 5. Like I said, look, equals -2. And if I evaluate this f, or solve f of x, when does f of x equal, let me hide this. When does f of x equal 28? Let's zoom out. Does it do it? It does, but it only gives me, no, it doesn't. It draws f of x equals 28, so no, it doesn't solve the equation for me. I would have to actually write in the equation. So that would mean that I would have to get rid of this, set it equal to 28, and then it does solve the equation for me. And it gives me, again, my two solutions, which again are the x values. My x value of 0 and my x value of 11. So I can use, again, that shortcut and see that these answers were 0 and 11. If I want to do the second part and figure out when does this equal to 28, that will require, let me erase this, that will require us to get x squared minus 11x plus 28 and equal it to 28. Again, just like what I wrote on Desmos, but do it by hand. I would need to, because it's a quadratic, is set this thing equal to 0. So I need to move everything again to the same side as the quadratic side. So x squared minus 11x plus this 28, and the one that I'm moving over is going to change from positive 28 to negative 28. And on the right side I have nothing, so that's going to be the number 0. Since these two terms are like terms and they're opposite, they're going to cancel themselves out, giving you, again, the 0 term also right there. So x squared minus 11x equals 0. So to solve this equation here, because we only have the quadratic and linear term, we use greatest common factor. So we'll factor out the factor of x, the greatest common factor of x. And we end up with this. And this means that x equals to 11, or the other factor of x minus 11 has to equal to 0. So x equals to 0. I think I said something different right now. Just realizing x equals either this equals to 0 or x minus 11 equals to 0. So you see, that's how I get the 0 part from there. And you can see how I get 11, because x minus 11 has to equal to 0. Then that would mean that the value of x would have to be positive 11. Positive 11 minus 11 is equal to 0. So that's how we get those two answers if I'm going to do this by hand. But you can use the shortcut like I showed you. Now for question number 8, there is no shortcut for this. You have to do this by hand. Desmos will not be helpful for this to find the inverse, even though we're setting up an equation. And we start by first switching the x and the y. Since this is y and this is our x, we're going to interchange those and get the following equation. Negative cube root of x minus 4 plus 7 equals y. And like I mentioned, we're going to change the x and y values. So let me interchange those. That should be a y, and this should be our x. So let's solve this equation. So to do that, the first thing that we need to do, again, because PEMDAS We'll simplify this. We want to undo PEMDAS. So starting from the bottom, we want to get rid of any outside addition or subtraction. So that would be this 7 here first. So we're going to subtract that 7 from both sides. Now from here, so we got done with this. Now we need to look for any multiplication or division on the outside, and we do. We have the multiplication of -1 outside right here in front of this radical. So we're going to now divide everything by -1. And because we're dividing by -1, that's easy to do. Normally I would leave it like that, but because it's -1, that just simply means that the x is going to become negative and the 7 is going to become positive. It's just simply going to switch the signs. So that way we don't have to look at this ugly fraction. And we just simply change the signs. So very convenient that we're dividing by -1. If it was any other number, like if it was -2, then I wouldn't divide because I don't want to divide 1 by -2 to get a decimal and 7 by -2 to get a decimal. But again, the convenience of dividing by -1. Now, the next step after this, again, is exponents. We want to get rid of any exponents, which we do. We have, again, here the exponent of 1/3. The cube root is the exponent of 1/3. So to get rid of that, we use the reciprocal exponent, which will be 3. So we're going to raise both sides to the third power, which then now is y minus 4 and -x plus 7 to the third power. And now we can finally work within the parentheses, whatever's left in the parentheses, which is the -4, by simply moving the 4 to the other side. Or in other words, adding 4 to both sides. So our inverse will be -x plus 7 to the third power plus 4. And you'll only need to write this part. Let me box it in. Only this part that I'm boxing in blue. That's the only thing that you need to write inside again our answer box. Because as you clearly see, I have already that notation for us as the prefix to the answer box. So no need to write the f inverse of x. So avoid that. Question number 9 can be found in the next page. This one right here. And the idea of this one, again, is since we're looking for the value of f inverse at 26, because of the x and y value switch, finding out the output value of this thing is the equivalency of finding out the input that gives me the value of 26 to the function. Because remember, the relationship between the inverse and the function is that the input and output values are, again, switching. So if I can figure out the solution to this equation, figure out what value of x gives me this number here, then that would be the number, again, that we get out when we plug in the number 26 into this inverse. So we want to solve this equation here. We want to figure out when is -4 times the cube root of x plus 2 equal to 26. And you know what? Because I'm running out of space here, I don't want to solve it by hand. I'm just going to use the shortcut of Desmos and have Desmos solve it for me. And there's two ways of doing this. I can write it all in one entry line. So -4 times the cube root. Now, it's not this one right here. This one is your square root. The cube root is going to be found under functions. And you have to scroll all the way down. You'll find it right there. You'll notice that it is located in the number theory on the third row, second column of the n, the root with the value of n, with that little n right there. So I click on that. I'm going to get that the cursor moves to the index. So I'm going to write the number 3 in there. Inside the root, I'm going to write in my variable x. And now I'm going to move to the right so I can be on the outside. Because if I type in +2, the +2 is on the inside. And I don't want it to be on the inside. I want it to be a vertical shift. So I'm going to move to the right. plus 2. And I want this equation or this expression to equal 226. Notice I'm not writing f of x, nothing like that. I'm just writing the equation, the actual numerical rule for the function, and setting it equal to 26. If I write, again, f of x, then this is not going to work. Okay? And this is what I was afraid of. This, again, I'm clicking on the graph, but it doesn't tell me what that point of intersection is. But if I zoom in, okay, I see that that number is negative 116. But if you want to avoid that and not have to actually zoom the way in to see what that number is, negative 216, what you can do is this option instead, okay? So instead of equaling to 26, instead of doing this, what I'm going to do instead is I'm going to, on one line, I'm going to write y equals, so it could give me the graph of this function. And on the second line, I'm going to write y equals and what I want it to equal to. I want this first line, this first y, to equal to 26. So if I do that and I scroll out, it's going to draw two graphs, and the intersection of those two graphs is going to be the x value of that intersection is going to be the solution to this equation. So since they intersect at negative 216, that is your answer. So like again, like I showed you, like I mentioned again, you don't have to, if you don't want to zoom in like I did right there, you could do this instead and just write again one and write the other. I don't think you have to put the y equals on this one in order for it to graph. No, yeah, you see it still draws a graph of this, but you do have to write y equals if you are going to put the number 26, because if you just put 26, nothing is going to happen. You have to actually equal it to the value of y, not x, okay, not x, it has to be y. And then it's going to draw you a horizontal line, and the intersection is 216 like I mentioned. So there's your answer. Negative 216. So we're halfway done. This is number 10, or almost halfway done. So let the table below represent the invertible function f at selected value. So this is again the table for f of x, and we want to evaluate the inverse of this table at 4. So instead of drawing another table for the input and output values of f, let's just relabel this. And understand again that all we're doing is again flipping, that the inverse is going to flip the inputs and the outputs. So let's read this as the inputs and this row as the outputs of the inverse of f. So if I want to evaluate the inverse of f at 4, using this row as the inputs, we're going to look at 4, and we see that the answer is 7. And we're going to also, for the second one, again, use the exact same row and look for where x is negative 9. And we see that that is negative 9 as well. So there are your values. Now we're at the halfway marker. So for number 11, we want to determine which numbers are excluded from the domain. So what numbers will make this function again have gaps. So there's two options. I can graph this and see where the graph breaks apart. Or the other option, which I think is more convenient, is to simply identify the values that are going to make the denominator, which is x squared minus x minus 30, equal to 0. And because I want to solve that equation, I can use again decimals as my shortcut. So let's use decimals again as a shortcut for this. So we have again x squared minus x minus 30. We're going to set it equal to 0. And hopefully again, yep, when I click on the point on the graph, it tells me the x-intercepts, and those are the values. So negative 5 and 6. So what that means is that since these are the numbers that make the denominator of this rational function equal to 0, positive 6 and negative 5, those are the numbers that are going to get excluded from the domain. So that would mean that if I graph this, look along the x and y axis, graph this entire thing, the graph would be broken apart, and the graph would again have these gaps, one at -5 and the other one at +6. Okay. No, it would have to look like that at 1. Okay. It will have again these gaps at these two x values of -5 and 6. So those are the two numbers that are excluded from the domain. So again, it's just solving the equation for the denominator, and those numbers get excluded from the domain. Question 12 can be found on the next page. This one right here is question 12. And we're asked to perform the following indicator operation, which is simply the ratio, of f divided by g of x. So we just want to get f of x over g of x, which is simply 8x plus 9 over negative 9x plus 3. So that's the answer that's going to go right there. Now, to figure out the inequality to state the domain, well, very similar to just the last problem that we did. All we need to do in order to identify what numbers of x are going to be excluded, but this time you actually have to write, again, this notation here to figure out what number is going to be excluded from the domain of this thing. We're going to get our denominator, negative 9x plus 3, and set it equal to 0. This one is a really simple one. You could use, again, Desmos. You go back to Desmos, type in this expression, and do the same thing that we did in the previous problem. Or let's just do it by hand because it's a very simple one. All you have to do is move the 3 to the other side, making a -3. So negative 9x equals -3. Dividing by -9. This reduces out, and that number right there reduces to a positive 3 over 9, or 1/3. So 1 over 3. If you know you did this one right and your answer is marked incorrect, double check that you simplify this fraction. So it might be marked incorrect if you don't simplify it, so be aware of that. And again, try various examples of this. I would, again, after getting this one right one time, I would try it again, make sure that I could do again this right there, and verify that you simplify again that fraction. And this is probably a good reason why you wanted to do this by hand, because if you did this using Desmos, you're going to end up with this decimal value. And if you're not familiar on what the equivalent fraction form to this decimal is, then typing that decimal in would not mark it correct, even if you write the x not equal. So if you were to write x does not equal to 0.333, you might not write enough threes for the computer to understand that your threes are supposed to repeat infinitely. So just better safe to use a fraction notation instead of that repeating decimal notation. Now we've done several problems similar to number 13 where we're doing a composition. The only difference is that we're now using graphs in order to do a composition. So our ability to answering this one correctly is correlated or is determined again by our ability to determine again the output values using a graph. So here again, because we're doing this composition, f of g of 0, fog of 0, we have to first start by evaluating g of 0. So from the graph on the right side, the one in red, g of 0, when x is equal to 0, is that point right there. So this point has a value of 0 and an input value of 0 and an output value of 1, which means g of 0 equals 1. So if I replace this with the value of 1 in the parentheses, our second step, so step 1, our second step is now to plug in that answer of 1 into f, which is represented with f, which is represented by the graph of on the left, the one in blue. So looking at x equals 1, we're now going to see that the output value is 2, which means f of 1 is 2. So that is our answer. Now, question 14 is another question that was cut off from the previous page. And on this example, we simply want to draw a line on the interval given here from, in this situation, from 1 to 3. So using the tools that are available on the actual review online, you would have to first draw your segment, which was going to go from 1 to 3. So drawing your segment from 1 to 3, and then putting the appropriate endpoints on each end. Because we're not including one, we would have to put the open circle on this end and the closed circle on the right end. Now for question 15, we have that we want to determine the domain of a square root, not a rational, a square root function. And to do that, that simply requires us to get the radicand, this value inside the square roots, 3x plus 3, and set it to be greater than or equal to the value of 0. So we're going to solve this equation by subtracting 3 to both sides. 3x will be greater than or equal to a negative 3, and then we're going to divide by positive 3. So we do not have to switch the inequality. Even though our answer is negative, we don't have to switch the order of this inequality because we're not dividing by a negative 3. That only occurs again had we divided by this value that we're multiplying with x was negative, and we had to divide by a negative 3. Then this would switch to the opposite direction, still equals, but it would be less than, and our interval will be in the opposite direction of what we have here. So here, all of our x values have to be greater than or equal to negative 1, which in interval notation we'll use again a box on this end because we're going to start at negative 1 and go to infinity with the round parentheses. Moving on to example number 16, we have two functions, and now we want to perform the addition operation and subtraction operation to our two given functions. So starting off with the addition one, we have 3x squared plus 6x plus 7, and we're going to add 9x squared minus 4x minus 3. And to add these, we just simply combine like terms. So this gets added, and I'm going to highlight again our operation, gets added with 9, and that's a total of 12. X squared this combines with this. Because they're different signs, adding two numbers of different signs actually subtracts them. And then the last set of like terms, that's going to become again the same as before, because one's positive, one's negative, we actually subtract them. And that is plus 4. Yes, 4. Okay. Now for the second one, for part B, we want to now subtract them. So for part B, we're going to do 3x squared plus 6x plus 7, but subtract it from 9x squared minus 4x minus 3. Well, to do a subtraction problem, remember that's the same thing as adding the opposite value. So I'm going to do the keep change opposite. So I'm going to change this operation from this operation. I'm going to change it to addition. And I'm going to change these values in here to their opposite value. So positive 9 will now be negative 9. Negative 4x is now positive 4x, and minus 3 is now plus 3. And I'm now going to do the exact same thing that I did in example A. Add up all the like terms. So I'll add up my squares, add up my linears, and my constants. So we'll end up with negative 6x squared, 10x, and 10. Question 17 was cut off from the previous page, and it starts here. The table below gives you values of the function f and g at selected values of x, and we want to determine the composition using the table. So for this one, I highly recommend that you actually take the time and split up these tables. The x values are going to be the same. We're not switching anything. We're not flipping. We're not doing inverses, just regular functions. So -4, -3, -2, 1, 3, and 7. So I'm just simply, if you didn't notice what I'm doing here, I'm just grabbing all of these x values and again making these the x values and separating again the table for the y values for g. So it makes it a little bit more convenient. Instead of trying to jump back and forth in the same table, I can jump back and forth from table to table. So I could ignore this now. So to do this evaluation for part A, step 1 is to first figure out what does g of -7 equal. So what is the inside part going to simplify to? So since g is the function on the left, we're going to do -7 and see that the y value is -4. So this equals -4. So now step 2 is to plug that into the f function. And if I look at the f function here, so now to do this, we're going to look at the x value of -4 and see that the y value is 1. So the answer to part A is 1. Now to do part B, let me move this over. To do part B, we do the exact same 2 steps, but in the opposite order. So part B, we want to now do g of f at -2. So we'll begin by first evaluating again the inside part. So using again the table on the left for f, we're going to look at the x value of -2, and we see that that value is 7. So we're going to replace this with -7. And we're going to plug in that -7 into the outside function g. So our second step is now to look at the table on the right, look at -7, and see that again, that answer is -4. So we get -4. This gives us again -4. And like I mentioned earlier, I forgot to write this down, that gave us an answer of 1. So there is the answer for part B. Now moving on to number 18, we're going to assume here that the function f is a one-to-one function. So f of 4 equals 7, and we want to find the value of the inverse of f at 7. Well, because it's a one-to-one function, that means that the inverse, f inverse, is also a function. So what that means is that when I look for the solution of this, there's only one possible solution. And because the inverse and the function simply switch the x and y values, then that would mean that this answer right here would have to be +4. Since f of 4 is equal to 7, then that would mean that the inverse of f at this output has to be the input. So the same thing is going to be true with the second one. Assuming again that this is an inverse, f inverse of -7 gives you an output value of -6. So that means that the input value of -6 into f will give you the output value of -7. You will find question number 19 on the top of the next page. And we're given a function represented by this table shown here below. And we're going to do two things. First, we want to figure out the value of f at -9. Again, the actual value of the function. So we don't have to create again an inverse of this. So f of -9 means that we're going to look at the input of -9 and see that the output is 58. And for the second part, we want to now do it backwards and figure out what the x value is so we can get the output of 51. So if we look right here, we see that at -8, that's the one that gives me the output of 51. So the answer to this solution, to this equation would have to be -8. And we finally reached the conclusion to our review. Question 20. Now we want to first find the domain and the range of this thing, but we need to make sure again that we write it in interval notation. So again, those are using, again, one of these symbols, both parentheses, bracket parentheses, or the opposite order, or two brackets, whatever the case is, okay? So recall, again, for the domain, we want to simply identify how far to the left does the fraction, so if I was to draw a vertical line, what's the farthest that the vertical line will reach that's still intersecting the graph? So if I draw a vertical line over here to the very far left, I'm not touching my relation, my graph. So I would have to move further from the left to get to that position right there, okay? And then from right there, I will then continue moving to the right until I touch the graph or the relation one last time. If I move any further, notice that this vertical line does not touch the relation anymore. So that would be this last point right there vertically. So the domain of these is going to be the x-intercepts of these two vertical lines with the relation, which is at -5. This value right here is -5. Let me do it in black, -5. And this number right here is -2, which clearly you can see right there. So we're going from -5 to -2. And because we have an open circle on the left end, we have to use parentheses to indicate that. And a closed circle on the right uses a bracket. Now to identify the range, we do the same concept, but now using a horizontal line from the bottom going upwards. So I'm going to move this horizontal line until I find the lowest possible point, which would be the first time I intersect this red line with the graph, which is going to be at this value there. And if I duplicate that and I continue moving upwards from there, notice that I'm still intersecting the relation, so I'm not stopping there, so I'm not stopping here. And I'm going to move it until I touch the relation one last time. If I go any higher, I don't touch the relation anymore. So I need it to be right there, okay? And this one will be here. This one is not going to be at this endpoint because notice that if I make my relation here, this point is intersecting, but there's pieces of graph that are still below. So I want to find again the lowest part. So when you start from the bottom, it's the first time you intersect the relation. So right there. Now those lines are going to intersect the y values, and we intersect the y values as you see right here at this positive value of 1 and at this positive value of 9. So our range is going to reach values of y from 1 all the way to 9. And because we have a closed circle here, again, indicated by having a continuity, again, no gap here, then we're going to include that value. So we have to use a bracket. And the 9, because of the open circle, would have to use the round parentheses. So there you have your domain and range. So that concludes our examples for the review. And just as a friendly reminder before you log off, make sure that you do the actual review that's posted on your course calendar for extra credit. 10% of the grade earned there will be added to this first test. Again, I appreciate you watching, and I really do hope that these videos and these explanations, these examples I went over were helpful. Thank you.